I noticed you guys were having trouble today, and in some of the classes we didn't get through everything. So I'm going to try to associate the graph of a function with the graph of its derivative. In this first problem, I've given you a red graph, f, and I'm going to sketch f prime. This is supposed to be 3 line segments. One here to the left of -2, one between -2 and 1, and another line segment from 1 off to infinity. If you count slopes over here, the slope of this piece is 1. To the right 1 and up 3, to the right 1 and up 3. So that means at any point in this place, if I'm graphing f prime, the derivative of f, it will have a value of 3. The slope of f is 3. F prime is 3 at the same spot. The slope of f is 3. F prime is 3 at the same spot. The slope of f is 3. F prime is 3 at the same spot. So I'm going to draw this horizontal piece. And where is the slope of f3? Well, everywhere to the left of -2. Up to, but not quite, at -2. So this is the beginning of the graph of f prime. In between -2 and 1, this graph f has a negative slope. So I'm not going to continue this part of the graph of f prime. That's a slope of -1, -1, -1. So at this spot, -1.5, f has a slope of -1, f prime is equal to -1. F has a slope of -1, f prime is equal to -1. F has a slope of -1, f prime is equal to -1. So the graph of f prime in between -2 and 1 would actually be a line segment at -1. What's going on here at 2? Well, nothing. F doesn't have a derivative, doesn't have a slope here at -2, so neither of these endpoints are going to be filled in. Let's count off the slopes here to the right of 1. That's down 1 to the right 2, down 1 to the right 2, down 1 to the right 2. So everywhere over here, f has a slope of 2. So f has a slope of 2, f prime is equal to 2. F has a slope of, -2. Come on, Shoal, get it together. A slope of -2, a slope of -2, a slope of -2. So these 3 pieces all together are what the graph of f prime looks like. Let's get rid of some of these dots and make that a little cleaner. Okay, let's go in the other direction. Here's a graph of a derivative. We're going to try to graph the original function. This is a little more complicated. So this is a graph of a derivative. Over here, g prime is greater than 0. Where does that start? That's to the right of x equals 3. To the left of x equals 3, g prime is less than 0. And at 3, g prime is equal to 0. Let's think about this for a moment. G prime is the derivative of g. So that means the slope of g of x is positive. Over here to the right of 3. What does it mean if g prime is less than 0? If the graph of g prime is below the x-axis, that means the slope of g of x is negative. So we need to draw a graph that has a negative slope to the left of 3 and a positive slope to the right of 3. Can we do any better than that? We sure can. So what is the slope of g at 4? Well, it's this y value 1. What is the slope of g at 5? The slope of g at 5 is 2. The slope of g at 2 is -1. The slope of g at that's not -2. that's 1. The slope of g at 1 is negative 2. So I'm going to try to draw a parabola here. And that parabola needs to have a slope of negative 1 at 2, a slope of positive 1. Let's see, a slope of 2 right here, which isn't terribly steep, a slope of negative 2 here.